In this video, we're going to continue practicing graphing sine and cosine functions with new amplitudes and periods and phase shifts, etc. So look, I have this a value right here of 6. And that a value tells me that the amplitude is going to be 6. Now, I've got this b value right here, and the b value is pi. Now, the b value indirectly gives us the period, because the period is always 2 pi divided by the b value. So that means the period is going to be 2 pi divided by pi, which means that the period is going to be 2. That is interesting. Now, nothing is being added or subtracted, so there is no phase shift. So I'm going to just go ahead and say none. This should be enough information for us to sketch this graph. So here we go. Because the amplitude is 6, I'm going to go up to positive 6, and I'm going to go down to negative 6. Because the period is 2, I'm going to come all the way over here and put a 2. That means if I go halfway, this should be simply 1. If I go half of that, this should be 1/2. And if I go between these two, it should be 3/2. Alright, 1/2, 2/2, 3/2. Okay, so this is a sine function. So that means it's going to start off at 0, at the midline. And then it's going to go up to its highest value, back down to the midline, down to its lowest value, and back to the midline. So since there's no phase shift, this is simply the final answer. Okay, let's go straight into number 26. This is the a value right here. That tells me that the amplitude is going to be 2. This is the b value right here. So the b value indirectly gives you the period, because the period is always 2 pi divided by the b value. So that means the period is going to be 2 pi divided by pi over 2. So that means that the period is 2 pi times 2 over pi. The way you divide by a fraction is you multiply by the reciprocal. So that's what I'm doing. But if I multiply these, notice that the pi will cancel out. I have this pi up high and this pi down low. These pi's are going to cancel each other out. That just leaves me with 2 times 2, which is 4. So the period is going to simply be 4. Notice it's not 4 pi, it's just 4. 4 radians. There is no phase shift. There's nothing that's being added or subtracted on the end. So for the phase shift, we're just going to say none. Now, this should be enough information for us to sketch the graph. Since the amplitude is 2, I'm going to go up to 2, and I'm going to go down to negative 2. Since the period is 4, I'm going to come all the way over here, and I'm going to put a 4. If I go halfway, that's going to be 2. If I go half of that, it's going to be 1. That means right here must be 3. Now, this is a cosine function. The cosine function starts out at its highest value, and then it falls down to the midline, this is going to be the final answer, so let me do this in blue. It's going to start off at its highest value, fall to the midline, and then it will drop to its lowest value, return to the midline, and end at its highest value at the end of the cycle. So this is the final answer. And that's it, since there's no phase shift or anything. Alright, these graphs are going much quicker than the other ones did. Let's see if our luck holds. So looking at number 27, here is our A value right here. That tells us that the amplitude is 1/2. This is our B value. Alright, everything here in front of the X is the B value. Now that will indirectly give us the period, again, because the period is always 2 pi divided by the B value. So the period is going to be 2 pi divided by 2 pi. So the period is going to be 1 radian, not pi, 1. And there is no phase shift. Nothing's being added or subtracted on the end. So this should be enough for us to do the graph. Okay, phase shift, none. So the amplitude is 1/2. So that means I'm going to go up to positive 1/2, and I'm going to go down to negative 1/2. Since the period is 1, over here I'm going to put 1 at the end. Then if I go right in the middle, this should be 1/2. If I go half of a half, that is 1/4. And if I go here, this should be 3 times 1/4, so this will be 3/4. So this is the sine function. So the sine function is going to start at 0, and then it's going to go up to its highest value, fall to the midline, drop to its lowest value, and back to the midline. So this is what the final answer should look like. Okay, let's keep going. Alright, now we're getting back to the more challenging problems again. Before I can really even read this graph properly, this equation, I have to be careful. I have a B value, and then I have some type of a phase shift. But guess what? The phase shift will not be pi over 2. I have to factor out the 3. So remember, it works like this. If I take my 3x minus pi over 2, before I read the phase shift, I have to pull that 3 outside of parentheses. I have to factor it out. And when you factor something out, to find out what goes inside the parentheses, you must divide. So that's going to leave me with x minus. So the question is, what is pi over 2 divided by 3? Now when you take a fraction and you divide by a number, all you are really doing is you're putting that number in the denominator. So this is really going to be pi over 2 times 3, or pi over 6. Alright, so pi over 2 divided by 3 is pi over 6. Okay. So this is really the phase shift, pi over 6, not pi over 2. So let's rewrite the equation in this form. So I now see that I have y equals 5 times the sine of Now inside of here I'm going to put this. So I have 3 times x minus pi over 6. Okay, now I can read what's actually going on. So this is my a value right here. So the amplitude is going to be 5. This is my b value. So that will indirectly give me the period. The period is always 2 pi divided by that b value. So that's why the period is going to be 2 pi divided by 3, because the b value is 3. Alright, so the period is 2 pi over 3. Now the phase shift is pi over 6. Not pi over 2, pi over 6. Remember that the phase shift is going to be the opposite of what you see here. That's why, since it is negative pi over 6, the phase shift is actually positive pi over 6. The phase shift is super useful in constructing the graph because we can start drawing the graph at the phase shift. So make your first mark and put the phase shift at that mark. Now, make 4 additional marks going to the right. So 1, 2, 3, 4. Because we made 4 marks, each mark represents 1/4 of the period. So let's figure out how big a quarter of a period is. And I'm going to call that a quarter period, QP. Well, so the period is 2 pi over 3. So the quarter period is going to be 2 pi over 3 divided by 4. Now, when you divide a fraction by an additional number, all you really have to do is put the new number in the denominator. So I'm dividing by 4 now. So the quarter period is going to be 2 pi over 12. So the quarter period is pi over 6. So to get from one mark to the next, I'm going to add a quarter of a period. So I'm going to add pi over 6. So if I take pi over 6 and I add pi over 6, that's going to give me 2 pi over 6. Now I'm going to temporarily put this up here. So I've got 2 pi over 6. That's going to reduce to pi over 3. Alright, but if I take 2 pi over 6 and I add another pi over 6, that's going to be 3 pi over 6. But that will reduce down to pi over 2. Now if I take 3 pi over 6 and I add another pi over 6, that would be 4 pi over 6. But that will reduce to 2 pi over 3. Now if I take 4 pi over 6 and add one more pi over 6, that's going to be 5 pi over 6. So these are the 5 markings that I'm going to need. So I'm not going to need these. Now I am going to put a couple of additional markings on here because we need to see where the y-axis is going to be. So if I go to the left, now I'm going to subtract a quarter of a period. So I'm going to subtract pi over 6. And that will tell me what the marking will be. But if I take pi over 6 minus pi over 6, that is 0. So that means the y-axis is right here. Okay, now let me make a little space for myself. So I'm going to go ahead and just draw the y-axis here. Whoa, that's bad. Let me try that one more time. Okay, so there's my y-axis. I see that there is an amplitude of 5. There's no vertical shift happening, but the amplitude is 5. So I'm just going to be really careful to label this properly. So I'm going to have 5, and then way down here I'm going to have -5 because of the amplitude. So I think we're ready to do the graph now. So this is the sine function. Don't forget, we're starting at the phase shift, pi/6. The sine function starts at the midline, and then it goes up to its highest value, back to the midline, down to its lowest value, and back to the midline. So this sine function, okay, I apologize for the weird mirage effect over there to the left. Just ignore that. So that's what this graph will look like. This is problem number 28. And again, as we look at number 29, we have to be very careful. I see that we have a b value here, and then we have this number that's trying to be the phase shift. But guess what? Pi/4 is not, I repeat, not the phase shift. The reason why, you have to factor the 1/2 outside of the parentheses before you read the phase shift. So look, if I have 1/2 x minus pi/4, in order to read the phase shift, I need to pull this 1/2 outside of parentheses. To figure out what goes inside the parentheses, you have to divide. If I'm taking out 1/2, I have to divide each of these by 1/2. That way these will cancel out and I will just have x. Now if you want to do pi/4 divided by 1/2, okay, dividing by a fraction is the same thing as multiplying by the reciprocal. So pi/4 divided by 1/2 is the same thing as pi/4 times 2. Or 2/1. So that would just give me 2pi/4, which reduces down to pi/2. So that's what goes inside the parentheses. So if I did this division and I got pi/2. So this will be x minus pi/2. Okay, so I'm going to just rewrite this equation using this form. So that means I have y equals 3 cosine. Okay, but now on the inside of here, I'm going to put this. So on the inside of here, I have 1/2 parentheses x minus pi/2. So x minus pi/2. Okay, and this is the form we must use to judge the phase shift. Alright, so take a look. This is the a value. So that tells me that the amplitude is 3. This is the b value, the 1/2. That indirectly tells me the period, because the period is always 2 pi divided by the b value, which means that the period is 2 pi divided by 1/2. And when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So that means that the period is 4 pi. So the period will be 4 pi. Now the phase shift is pi/2, not pi/4. We had to factor out the 1/2, and that left pi/2. And it's the opposite of what you would think. So because we have negative pi/2, that's why the phase shift is actually positive pi/2. Now, the phase shift is so important for drawing the graph because the phase shift tells you where to put your very first mark on the x-axis. So, alright, the phase shift is pi over 2, so we'll go ahead and put our first mark at pi over 2. This line is a little bit too crooked. I'm dealing with some artifacts on the screen. Okay, so put 4 more marks down. 1, 2, 3, 4. Because I put 4 marks, each one of these marks will represent 1/4 of the period. So let's jump over here and figure out what a quarter period will actually be. So it's actually going to be really simple for this problem. A quarter period is 1/4 of the period. So the period is 4 pi. So if I take this and I divide by 4, then that's a quarter of a period. So the quarter period will be pi. That's important because as I go from one mark to the next, I should be adding a quarter of a period each time. So I'm going to be adding pi. Now, pi is easy to add. We need like denominators, but I can think of pi as 2 pi over 2. Boom, like denominators. So if I take 1 pi over 2 and I add 2 pi over 2, that's going to be 3 pi over 2. And if I add another 2 pi over 2, that's going to be 5 pi over 2. And if I add another 2 pi over 2, that'll be 7 pi over 2. And if I add another 2 pi over 2, that will be 9 pi over 2. Okay, so those are the 5 marks I'm going to use. Now, in addition to this, I'm going to put another mark or 2, depending, because I need to see exactly where the y-axis is going to be. So I'm going to put another mark to the left. If I'm going to the left, that means instead of adding 2 pi over 2, I need to subtract 2 pi over 2. So 1 pi over 2 minus 2 pi over 2 is going to be negative pi over 2. So the y-axis is at 0. So when I see a negative number and a positive number, I know that the y-axis is going to be in between. Alright, so let's go ahead and draw the y-axis right in here. I think I'm going to change colors this time. I'm going to go green with it. Alright, so the y-axis is going to be like here. Now, the amplitude is 3. There's no vertical shift, but the amplitude is 3. So that means the high value should be at 3, and the low value should be at negative 3. Okay, I think that's all we need to do the graph. This is a cosine function. That means it starts at the high value. So I'm not starting on the y-axis. Remember, we start at the phase shift. So I'm starting at pi over 2. But I will start off high, and then the cosine function goes to the midline, and then it falls to its lowest value, and then back to the midline, and then it ends at its highest value. So ignore the mirage effect that's being created over there to the left. It's very distracting, but I'm going to try to ignore it. Okay, so this graph is going to look something like this. And that's it. That was problem number 29. Alright, be careful with this equation. One more time. Whenever you have a b value and you're trying to see a phase shift, you see that a phase shift is coming. You have to be careful because pi over 6 is not the phase shift. You cannot read the phase shift until you factor out the b value outside of the parentheses. So look at this. I have 1/3 x plus pi over 6. Now, in order to read the phase shift, I have to take this 1/3 and factor it outside of parentheses. I can do that if I divide both of these terms by the 1/3 that I'm pulling out. So I have to divide by 1/3. Okay, that way these are going to cancel out and I'm just going to have x. So I've got pi over 6 divided by 1/3. Well, dividing by 1/3 is the same thing as multiplying by 3. Alright, you multiply by the reciprocal. Okay, so this is like having 3 pi over 6. 3 goes into 6 twice, so this is pi over 2. So I will have x plus pi over 2. And this is the real phase shift. So just be careful. So when I create my function in a moment, I'm going to rewrite this part as 1/3 and then just like I have right here, I'm going to have x plus pi over 2. And this is where I will look for the phase shift. Okay, so I will write the rest of this. So I have y equals -5 cosine, and then the rest of it in the way that I've rewritten them. So now I am ready to look and see what I have. So this is my a value right here, that -5. That tells me that the amplitude is 5. The amplitude is always positive. This 1/3 is the b value. That indirectly tells me the period, because the period is always 2 pi divided by that b value. So the period is going to be 2 pi divided by 1/3. Okay, dividing by 1/3 is the same thing as multiplying by 3. So the period is going to be 6 pi. Okay, so the period is 6 pi. So notice that the phase shift will not be pi over 6 or even -pi over 6. Now that we have factored out the 1/3 outside of parentheses, I can see that the phase shift is going to come from this pi over 2. But it will be the opposite of what you see here. So instead of a positive pi over 2, the phase shift is actually going to be -pi over 2. Okay, now the phase shift is crucially important because it tells us where to put the first mark on the x-axis. So let's go ahead and draw the x-axis. And let's put our first mark at -pi over 2. So I'm going to put a mark right here and call it -pi over 2. Now put 4 more marks on the x-axis. So 1, 2, 3, 4. Now, because I made 4 spaces, and this graph is going to represent one period of the function, then each one of these spaces represents a quarter of the period. So let's calculate exactly what a quarter of the period actually is. I will call it QP, that stands for quarter period. So since the whole period is 6 pi, a quarter of the period should be 6 pi divided by 4. Alright, so but this will reduce down. So a quarter period is 3 pi over 2. That is significant because as I go from the first mark to the second mark, it should be increasing by 1/4 of a period. So since the quarter period is 3 pi over 2, I can add 3 pi over 2, and that will give me the next x value. Now luckily this is already having like denominators. Sometimes I have to create like denominators. But -1 pi over 2 plus 3 pi over 2 is 2 pi over 2. Alright, I'm putting it up there so I have space to reduce. Obviously this will reduce down to simply pi. Alright, but for the purposes of counting up these spaces, I'm going to still think of it as 2 pi over 2 for another moment. So if I have 2 pi over 2 and I add another 3 pi over 2, that should give me 5 pi over 2. Okay, now if I have 5 pi over 2 and I add another 3 pi over 2, that's going to give me 8 pi over 2. Alright, I put it up there to leave myself space to reduce. So this will reduce down to 4 pi. Alright, but let's think of it as 8 pi over 2 for one more second. If I take 8 pi over 2 and I add another 3 pi over 2, that's going to be 11 pi over 2. So we can erase all these like extra marks that we made, little helping marks. So these are the 5 x values that we're going to use for the graph. Now we need a y-axis in here somewhere, and I see I have a negative and then a positive. So I know the y-axis is going to be between here somewhere. But please do not get confused. This y-axis I'm about to draw is not one of the 5 marks. So when I put the dots on here, I'm going to ignore the y-axis. But anyway, the y-axis should be in here somewhere. Okay, so there's my y-axis. Now, the amplitude is 5. So that means it's going to have a maximum value of 5. There's no vertical shift, so the midline is still the x-axis. So if I go up 5 and down 5, alright, so this is -5, that should be the high and the low. So I think that's it. I think it's time for me to draw the graph now. So this is a cosine function. Normally cosine starts at its highest value and then it goes down. However, the negative sign in the front represents a reflection over the x-axis. So I need to do cosine upside down. So instead of starting out high and going low like a U or a V, I'm going to start low. Now remember, ignore the y-axis right now. We're starting at the phase shift of -pi over 2. So our first dot should go right here. And then I'm not going to put a dot on the y-axis. That's not one of the 5 marks. The next quarter period mark is here at pi. Okay, and then so that's at the midline. And then it will go to its highest point, and then back to the midline, and then down to its lowest point again. Alright, so this is going to make that weird mirage effect again. But it will jump to the right spot when I finish drawing this. Alright, so that is what your graph should look like for problem number 30. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.